Alright, so big T. How do I know how many petals are going to be on these roses? Speak up so they can get your answer. Or the silence that follows.
I guess you want to.
Don't say you guess, you say with confidence.
If it's even, you multiply it by 2. And if it's odd, you don't.
So, Brown, good job. Forgot to show. And Conley, your job is also to remind me of my microphone every day.
Okay, I can do that.
Alright, so you determine how many petals by looking at the n value in front of theta. If it's even, you multiply by 2. If it's odd, that's just how many there are. So 2 times 2 is 4 petals. The 5 out there tells you what ring that the petals go out to. So in this case, it goes out to the 5th ring. We'll also learn that if the n value is negative, not negative, if it is even, you're going to have 2 equations. 2 equations set one equal to 1 and one equal to -1. Alright. What sign value gives you 1? That's pi over 2. Divide everything by 2. That's pi over 4. You plug in n equals 0, n equals 1. If it's 4 petals and you have 2 equations, 2 petals are going to come from each. Down here, what sign value gives you -1? That's 3 pi over 2. 3 pi over 2. Divide by 2, that affects the denominator, so it'll be 3 pi over 4. So your 4 petals, 1, 2, 3, 4. Are there any questions on number 9? You good? What's your question, BT?
How do you get the 2 theta?
2 theta, it's right here. You remember those equations that we had set that equal to something plus 2 pi n? That's what we're doing here. That's why we learned what we did earlier. Alright, so here we're going to have 3 petals. Since this is odd, we set it equal. There's only been one equation set equal to 1. The reason we don't set equal to -1 because when it's odd, those values are going to repeat, so we only have to do one equation here. Okay, what sign value gives you 1? That is pi over 2. If I get this theta by itself, so I divide everything by 3, so that's going to be pi over 6 plus 2 pi over 3n. Let n be 0, so 1 is pi over 6. Plug 1 in, 2 pi over 3 plus pi over 6 gives me 5 pi over 6. Plug 2 in. It gives me 4 pi over 3 plus pi over 6 gives me 3 pi over 2. Alright, so I have, these are my 3 petals. I'm going to go out to ring 5, and that's what I did there. Let's do number 12 together. Alright.
So this is going to have 8 petals?
8 petals, very good. Now, it's going to be 8 petals. How many equations will I have on this one? 1 or 2? It's even, so you're going to have 2. You're going to set 1 equal to 1, 1 equal to -1. Okay? So, do I need to put that 3 there, or do I just put cosine 4 theta? Equals 1. I'm going to come down here. Cosine of 4 theta equals 1. What cosine value gives you 1? 0. So 4 theta equals 0 plus 2 pi n. Divide by 4. That's going to be pi over 2 when you reduce it. Do y'all see that? If I divide it by 4, 2 divided by 4 is half. Okay, if I let n be 0, that was 0 plus 0 is 0. Let it be 1. That's going to be pi over 2. Let it be 2. That's going to be pi. Let it be 3. 3 pi. Okay, this is going to be 8 petals. I have 2 equations. So I'm going to get 4 here. How many's going to be on the other equation? 4. So cosine of 4 theta equals -1.
Wait, how did you know when to stop?
If I plugged another one, if I plugged 4 in, you don't want, on these, you don't want 2 pi or above. That would give me 2 pi, wouldn't it? It would give me 2 pi. So, and plus 8 petals. If you're going to have 8 petals, buddy, you got 2 equations. 4 is going to come from this one, and I already have 4 right there. Okay. What cosine value gives you negative 1? Pi. I'm going to divide that by 4. That gives me pi over 4 plus pi over 2n. I'll let n be 0. That's going to give me pi over 4. I'll let that be 1. That's going to be 3 pi over 4. I'll let that be 2. That's going to be 5 pi over 4 when I add those. Then I'll let that be, okay, so I just did 0, 1, 2, 3, 7 pi over 4. I have 4 petals, so I got 4 here and 4 here. I'm all ready to graph it. What ring will I go out to? 3. Okay, so here we go. I'm going to graph 0, go out 3rd ring. Then pi over 4. Huh? Did I go out to the which one?
4.
Oh my word, I went out to 4. I should have went out to what? 3. I'm misstressing this up. Let me fix it on this one. Should go out to the 3rd one. Now I'm going to show you how to graph these in your graph calculator if you want to know for just a minute. And I can't do that at the moment because this is recording. So we're going to show that in the class after I finish the lesson.
Put a calculator up.
Oh, that's why you're my class. Alright, so if you look here, go to mode. And when you go to mode, it has to be in radian. And then here is your different coordinate system. You have function, parametric, polar, sequence. What type of function do you want to graph? So scroll over to POL. And then hit second quit. When you do that, when you pull up the y equals, it should be r's down the thing because that's what polar involves, r. And we want to graph 3 cosine 4. Now, when it's in polar, the x, your variable button, becomes a theta.
Whoa.
Hit enter and then graph. And you see there's your...
That's a pretty.
That's cool.
Mm-hmm.
Can you grab a heart?
Mm-hmm. You want to see one? Let's see here. 1 plus 2 sine theta. That's an inner loop, sorry.
2 minus 2 sine theta.
2 minus 2 sine theta. You can't really see the heart.
Ugly. That's a tomato.
Yes.
So would I click to make it switch from 1 to R?
You go to mode, and that 4th line, it should be POL highlighted. If you ever want, now, just so you know this, if you want to go back to y equals, you need to hit function. You see that? That's your traditional function. And then go back and put it in degree mode as well.
What did you do 4 minus 2 cosine?
Well, you try it out right there and see what you get. Okay, moving on. Here we go. Okay, well, I'm going to go on and cover the notes today, and then we're going to go over homework, okay? So turn over the page. The last type of graph we're going to learn is called a lambda-cent. Not a lambda-sun, lambda-cent. Do y'all see those? Lambda-cent. And how do you know these? These are the only ones that have r squared, okay? If it has r squared, it's a lambda-cent. These are very, very easy. Okay, if it's cosine, it's going to be on the horizontal, sine is vertical. Okay, let's remember that. So what you do is you put a point at the pole. Just like a circle, it has a point at the pole. And like a rose, there's a point at the pole. Now, you take the square root of the number right here. What's square root of 9? 3. Okay. So if it's cosine, you go out in 3 in both directions. 1, 2, 3. 1, 2, 3. And then draw this. And that's your answer.
Wait, that's it?
That's it.
So is it always going to be 2 theta?
Yes. Now sine, what's the square root of 8? Somebody find that for me. Take the square root of the number from the sine.
2 square root 2.
Okay, give me the decimal.
2.828.
Okay, 2.8. Okay. So on a sine, you always go up to the power 4 in quad 1 and quad 3. Put a point at the origin. Go out to 2.8. 1, 2, right here on the power 4. And that's your answer. Yeah, it sounds good. Thank you.
So sine is always pi over 4?
Yes, yes.
And what is cosine? Just
On the horizontal. Okay, let's do these at the bottom. It says identify each of the polar graph. We're just identifying. Number 21. What type is this? Circle. Somebody describe to me what you would do on that one. Would you have a point at the pole on this one?
Yes.
Would you go right or left 4? Right 4 on the horizontal or vertical?
Horizontal.
Okay, good. Number 22. What type is that? You got circle, lambison, cardioid, rose. Lambison. Okay, it's a lambison with the inner loop or dimple? Dimple. Because your A value, absolute value A, is greater than absolute value B. Do you see that? Are we sure? Scared me a little bit. Number 23. What type is this? Rose. We know that's a rose and not a circle because the number is greater than 1 in front of theta. How many petals would this have? 20. You multiply by 2. Number 24. What type is that? Lambison. Is it inner loop, dimple, or cardioid?
Cardioid.
Inner loop. When A is less than B, absolute value, is inner loop. When A and B are the same absolute value, it is cardioid. When A is greater, it's with dimple. Does everybody understand that? 25. What type is this? Circle. Okay. Would it be on the horizontal or vertical? Vertical. So would you go up 2 or down 2? Down 2. On number 22 and 24, you have to make a table, wouldn't you? Here you have to do the equations we just did. Number 26. What type is this? It has a specific name. Cardioid. Very good. That means it has a dimple at the pole. 27. What type is that? Rose. How many petals? 5. Number 28. What type is that? Lambison. That is a lambison. Is it dimple or inner loop? Dimple. Is it at the pole? No. Are we good on that? Okay. Let's go over our homework. What numbers did y'all have to do?
28 through 32, but not 31.
Okay. Check 28. That is a lambison with inner loop. It kind of went off, so I kind of extended it here. Number 29, that's a lambison with inner loop because your A is less than B. Are there any questions on 28, 29? I'm going to do 30 and 32 with you. All right. Number 31. Oh, not 31. What number are we doing?
30 and 32.
I only gave y'all one rose last night. That was super sweet last night. I was just over it yesterday, like I didn't care what you did. Homework. All right, what's your major points here? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Very good. I'm going to plug 0 in. What is cosine of 0? 1. So 1 times negative 3 is? Negative 3. Y'all talk to me. Negative 3. 4 and negative 3 gives me pi over 2. Cosine of that's 0, so that goes away, gives me 4. Pi, cosine of pi is? Negative 1 times negative 3. Plus 4 is? 7. 3 pi over 2 would be 4, because that will cancel out and give you 4. And the 2 pi would be?
Same as 4.
Yep. Alright, so go to the 0, go out to ring 1. Okay, pi, let's see here, 1, 3, 4, 5, 6. I want to extend it, make a little curve, put another point there. Where will my dimple be?
The one that on the right.
This right here. Y'all see that? Because these are the same line. That's furthest from both. So that's my dimple. All right, number 32. How many petals will I have here? 4. Okay, how many equations will I have here?
2.
So I'm going to say cosine of 2 theta equal 1. Cosine of 2 theta equals negative 1. What cosine value gives me 1? 0. So I put 0 plus 2 pi n. Divide that by 2. It gives me 0 plus pi over n. I'm going to let pi n be 0. So that gives me 0. Let it be 1. It's going to be pi. I'm going to have 4 petals. So that means I'm going to get 2 from here and 2 from here. Cosine value gives you negative 1. Which one gives you negative 1 is what? Pi. It gives me pi over 2 plus pi n. Okay, I let it be 0, so theta equals pi over 2. And then 3 pi over 2. So there's my 4 petals. I'm going to go out to what ring? 2. Yes, buddy.
I thought, like, at first you're supposed to divide by that first number.
Yes, but we talked about that. Yes, but we said originally yesterday we said this equal to 2 and equal to negative 2. But every time when you divide by this number, it's always going to be a 1 and negative 1. So we said we could skip that step.
That 2 theta would disappear, though, wouldn't it?
No, it would not. No, because if you divide this by 2, it's only going to divide this by 2. Divide that by 2. It's not gonna, that's like the inner argument right there.
Okay.
Yeah. All right, so we're going to go out to the second ring. And that is my flower. Okay. Are there any questions? Okay, I'm going to give you your 2 checkpoints to work on, and then you can work on your homework for the rest of the period. You have 15 minutes. So